project based on the US 2016 dataset. The dataset contains primary results from the 2016 US presidential election and demographic data of the counties in the US, including ages, races, genders, education levels, housing and living situations, income and poverty levels, and sales of different business fields.
For pre-processing, we first dropped the null values, and then we performed an important step of converting the long panel data, which takes each candidate as an entry, into wide panel data, which takes each county as a data entry. This makes merging primary results with the county demographic data possible under the FIPS code. We also created binary variables and the fraction of votes as continuous outcome for our further analysis. Our aim is to study what indicators that cause voters to vote for Donald Trump rather than other Republican candidates. As this is the primary results, we don't do cross-party comparisons, but we want to study how Donald Trump stands out from the other Republican candidates.
We observed some significant correlations among features, and we also ran a simple OLS model to choose features with extremely small p-value as our features in next steps. We first tried multiple transformations on each feature and got the best performed one by taking a few logs, squares, and square roots. And we fitted linear model using all two-way interactions of 7 single transformed features in our best transform model. Then we used stepwise regression based on the AIC using all of the two-way interactions. And we also fitted lossy regression on all two-way interactions with far-field cross-validation to choose lambda. As is shown in the form, we think our stepwise regression model is the best model because it has the largest out of sample R-square and lowest MSE. As it's in the stepwise regression model, we have 7 single transformed features and 12 interactions covering fields of housing, degree, age, race, poverty level, and land square.
For classification, we need different metrics, including the classic 0-1 loss and the AUC score, which is the area under the ROC curve. We used the similar features from before as our baseline model, and then we did transformation and included all the interactions, making it a total of 55 features. And then we did stepwise regression or lasso using the AUC or the loss as our metric. Out of these 4 models, we choose the best one, which is the lasso AUC. Here is how we selected alpha for this model. You can see the blue curve is the AUC score, the red dot line is the one standard error bound, and the yellow curve is the fraction of trimmed features. Around alpha equals to 20, this is where the elbow is. We choose this as our model hyperparameter.
For regression, on the test set, our model has a less MSE and larger R-square comparing to baseline model. So specifically, it indicates that in our counties with more people below poverty level, more white population, larger areas, larger owner-occupied housing units, and less people having bachelor degrees or higher are more likely to vote for Donald Trump than any other Republicans.
For inference of classification, the conclusions are similar, except that there is one extra indicator of less people below 18 years old. Our model is also better than baseline without interaction, but actually worse than using all interactions, which is probably because we have pre-selected all the important features first so that all their interactions matter and is not very likely to overfit. We did not do causal inference, but if we want to, we can select one out of these indicators and then perform methods like two-stage least square to determine the exact amount of the causal effect.
Thank you.